Continuing Basic Chemistry, Part 5, Endothermic and Exothermic Reactions. The New Mexico 8th grade science standards that this unit meets. And the unit essential question: how do chemical reactions help us examine the nature of matter? On page 92 of your notebook, you should have a T-chart where you make predictions and observations about what happens to a glow stick when placed in hot and cold water. If you missed class, feel free to Google this experiment and find out for yourself. Turn your paper to page 93 and set it up for Cornell note-taking. The essential question: how do endothermic and exothermic reactions compare? An endothermic reaction is a reaction where energy is required for it to take place. For example, in plants, photosynthesis is a chemical reaction that requires energy from the sun to create the sugar or glucose for the plant's food. So photosynthesis is considered an endothermic reaction because it requires energy to take place. An exothermic reaction is a reaction where stored energy is released to the surroundings. For example, a glow stick emits light energy to the surroundings. So a glow stick would be considered an exothermic reaction. It's really important to understand the law of conservation of energy. Energy cannot be created or destroyed. It can be converted, it can be transferred, it can be stored, it can be released, but it cannot be created or destroyed. The energy has to go somewhere. The next few terms are important terms to understanding the energy of reactions. The first term, activation energy. It's the minimum energy required to start a chemical reaction. Some reactions require different amounts of energy, but if the minimum is not met, then the reaction will not happen. For example, photosynthesis. If a plant does not get enough sunlight, it will not be able to run the reaction of photosynthesis. The next one, catalyst. A catalyst lowers the activation energy so that a reaction can happen faster, but the substance itself remains the same. The catalyst itself does not participate in the chemical reaction. It does not change into something new. It simply lowers the amount of energy needed so that the reaction can happen faster. An inhibitor is the opposite. It's a substance that slows down or stops a reaction. So again, the inhibitor itself does not participate or change in the reaction, but it does slow down a reaction or even stop a reaction. All right, you're going to use these terms to help you work through the energy of reactions graphing activity. And then when you've completed that, you're going to continue to work on the choice projects.